So another important part that you really need to write down in your book for the theory is the operations on complex numbers, okay? Now this is adding, subtracting and multiplication by a scalar. Scalar means a number, okay? So adding and subtracting, they're essentially the same. The key thing is that you need to look at your real parts of your complex numbers and you add those together or you subtract them in the order that's specified, and then you look at your imaginary parts and you add those or you subtract them depending on what you're doing, and multiply by I. Okay, so essentially it's all about just adding and subtracting the real parts and the imaginary parts separately. For a scalar, the key thing here is it's like expanding over a bracket. That's really all it is. So the scale and whatever the number is out the front will multiply both the real and imaginary parts, okay, of your number. This is only when k is a real number. So let's have a look at this example. We've got z1 equals 2 minus 3i. So that's our first complex number, and z2 equals 1 plus 4i. It's always a good idea just to write them down so you can see them. So for a, we're going to look at z1 plus z2. So what we need to do here is just write down your complex numbers. There's z1 plus z2. Okay. Often it's a good idea to put brackets around the second one. Mainly just do that because if you have a negative here, you need to be careful that you're subtracting that through that bracket. Because it's an add, you don't really need to do it, sort of a step you don't need. And what we need to do now is look at the separate parts. So look at your real parts. So we've got 2 plus 1, so that's 3. And then just cancel them when you're done with them. And then you've got negative 3i plus 4i, so that's going to be plus 1i. And because that looks a bit strange to write it like that, you can just write that as plus I. So that means for our answer there, just to end that one, so therefore z1 plus z2 equals 3 plus I. So you've got that full solution at the end. B, we're going to do a similar thing. So we've got z1 minus z2 this time. So we write down z1, and this is why it's a good idea to use the bracket when you write z2. You can see now that you need to expand that negative through this bracket. So here, so it's negative 1, and also here, so you've got negative 4i. Now again, we're going to combine the different parts. So the real parts, 2 and negative 1. 2 take away 1, and you can, if you want to, you can sort of rewrite it so you can see what's going on. That's 1. Here we've got negative 3i minus 4i. So we've got negative 3, take away 4, which we know is going to be 7. So negative 3, take away 4. As you're doing them, I often cross them out so I can keep track. So that means that for that question, we know that z1 take away z2 equals 1 minus 7i. Okay, the last one, you could pause here and try and do this yourself, see what you end up with. We're going to look at C now. So I'm just going to give myself a little bit more room over this way. It's a little bit longer. Okay, so we've got here for C 3z1 minus 2z2. We've actually got a couple of scalar multiples here. So I'm going to write that as 3, bracket, write my z1 in. So this is my z1. So 2 minus 3i minus 2 outside a bracket of z2, which is 1 plus 4i. So now what we can do is use that expansion across the bracket. So we've got 2 times 3 is 6, minus, because of the minus 9i, take away. Now here we've got negative 2 times 1, which is going to be negative 2. And then here we've got 2 times 4, which is 8, and it's a negative, so negative 8i. Okay, putting everything together there, we've got our reals and our imaginaries, and I'll do this in another colour again. There are our real parts, so 6 minus 2 is 4. And our imaginary parts, we've got negative 9 minus 8. So negative 9 minus 8 is going to be minus 17i, with it, because they're our imaginary parts. So to finish that part off, I just write that down again. So therefore, 3z1 minus 2z2 equals 4 minus 17i. So what you're doing there is you're using all of those results for addition, subtraction and multiplication, always dealing with the reals separate to the imaginaries, and then simplifying if you can, cancelling down and combining them together for your final answer.